So today we are going to discuss about case study on magnetic materials, right? Okay, we all know about magnet, right? So what is magnetic materials?
Magnetic materials are the substance which attracts to magnets, such as cobalt, iron, and
Okay, very good. So what is magnetic field?
Magnetic field is the space around the magnet where the magnetic fields are present.
Okay, very good. The space around the magnet are against current carrying conductors. So that we feel some kind of field that's called as magnetic field, right? So what is magnetic dipole?
it is a system which has equal and opposite poles, which is separated by a small distance.
Okay, very good. So equal and opposite pole that was separated by a small distance that's called as magnetic dipole. Okay. So what is susceptibility?
It measures the materials which magnetize in a external magnet.
Okay, so now the material gets in. Now let us consider a non-magnetic material. We have converted into magnetic material. So how much amount of magnetization will be produced in that sample? That can be measured by using susceptibility, right? Okay, what's permeability?
It is a property of material which measures the how easily it can support the transformation of the magnetic field.
Okay, so how much amount of lines can be penetrate through the sample, which was measured by easily by using permeability, right? Okay, so how do you classify magnetic materials?
So magnetic material is classified based on whether it is having magnetic dipoles or not having magnetic dipoles. So it is of three types: para, dia, and ferro.
Okay, so we are classified into on the basis of having dipole and not having dipole. So by not having dipole, we have one type, right? So what is the type? Diamagnetic materials. So in does not having dipole, we have one type. So if having dipole, we have two different types. Okay, two different classifications. What are the classifications? Para and the ferro. So what is my diamagnetic material?
Diamagnetic material are the materials when there is no magnetic field and there will be no dipoles. When the external force is applied, then the dipoles will be created in the opposite direction. So some of the properties can be susceptibility will be less than unit.
Okay. Okay, which will repel the magnetic forces, right? So that the susceptibility will be in negative dimension and permeability also very much less than 1. Okay, so which is and the susceptibility will be independent of temperature or depending on temperature. This will be independent of temperature. So if you raise the magnetic field or raise the temperature, then there is no changes in these properties. Okay, so these are the properties of diamagnetic material, right? So in the absence of magnetic field, there is no dipoles. In the presence of magnetic field, there is a dipoles. But the dipole alignment will be opposite to the field direction, right? Okay. Okay, what is paramagnetic materials?
Paramagnetic materials, they have permanent dipoles. When there is no external field is applied, the dipoles are in irregular arrangement. When we apply an external force, it forms to a regular arrangement which attracts towards the magnetic field.
Okay, very good. Which will attract the magnetic line, suppose, right?
Yes.
The susceptibility will be
High.
High. Okay, it is in the positive. Okay, so the permeability also very much high. Okay, compared to dia, so this is a highly magnetic material. Okay, so these materials are depending on temperature. At particular temperature, that means Curie temperature, para becomes dia. So its properties get changed at a particular temperature. That temperature is called a Curie temperature, right? So what is in the ferromagnetic materials?
Ferromagnetic materials which have already have an arranged dipoles,
Okay.
even without external force,
Okay.
and it have a high susceptibility and permeability.
Okay.
And in certain temperature, it becomes paramagnetic called Curie.
Okay, very good. So ferro also so compared to para and ferro also having dipoles, but the dipoles, the arrangement should be so it has regular arrangement. Okay, so if we apply the force means the diamonds will get changed in the poles directions, right? So it has permeability is very high, susceptibility also very high. Okay, so these materials also depending on temperature. Okay, particular temperature change into para ferro becomes para. So the whole properties get changed, right? Okay. So what are the applications of magnetic materials?
They are used in artificial intelligence like storage devices. For example, public memories and magnetic.
So we can use in the storage division. Okay, that's all. Thank you.